Hi, welcome to How to Use Sonar to Map the Ocean Floor. My name's Gwen, and I'm doing this specifically for my 3rd, 4th, and 5th grade science class. SONAR is an acronym. It stands for Sound, Navigation, and Ranging. The important thing to know about sonar is it's man-made, and we use it to calculate distances. Echolocation, on the other hand, is something that animals can do. Echolocation, the animal will send out a noise and it waits to find out how long it takes to return to them, and from that the animal can figure out how far away something is. Marine mammals, cetaceans, such as dolphins and porpoises and whales, actually have a specialized part of their brain called the melon devoted to echolocation. A bat also uses echolocation. Now, sonar is useful for a couple of things. For one thing, boats and subs can find out how far away they are from other boats and subs. But what we're interested in here is how sonar is used to map the ocean floor. Here's a map around Maine of an ocean. If you notice, it looks like any old topographic map, but it's of the ocean. The deep blue, dark parts are deep in the ocean. The light cyan blue is higher up. You notice you have circles just like a topographic map. So if you imagine a boat going on this grid, kind of like Battleship, and you can imagine how it can create that map. Now, there's two important facts that you need to know about sound before you can start calculating. The first is that sound travels at a certain speed. It travels at different speeds in air and water. In fact, in water, it's 4.3 times faster than in air. In water, sound travels at about 1,500 meters per second. In air, it's 343 meters per second. That's dry air. And in water, it's actually 1,484 meters per second. Now, another important fact about sound is that it travels in waves and it bounces. So if sound travels, hits something, and bounces back. So here's an example calculation. I'm pretending to be the blue dot, and then there's that board or whatever it is, something that's going to reflect the sound. I emit a noise, it travels to the board, it reflects back, and then I hear it. Note that the total elapsed time was 2 seconds. The sound started at 4:20:02, it returned back 2 seconds later. So the distance that this was away, it only took half of that time because the other half was coming back to me. So I'm going to divide that number in two, and I get 1 second. Now there's this equation that you guys probably know. Distance equals speed times time. If you've ever been in your mom's car or your dad's car and they're driving along on the freeway, say they're going 60 miles an hour, and you know that there's 1 mile left. So you know you have 1 more minute before your mom exits the car. My son does this all the time. He figures that out in the car. Well, this is similar, except we've adjusted the equation a little bit. Distance equals rate times time. So to calculate our distance, we know our rate. Remember, that's 1,500 meters per second. That's the speed of sound in water. And we multiply that times our time, which was 1 second. And we end up with 1,500 meters second over 1 second. Now, if you remember your fractions, anything over itself is 1. If you multiply anything by 1, it's itself, and we don't care about it. So 1 second over 1 second is 1, and we can just slash through the whole thing there. We're left with 1,500 meters. So here's some boat. The boat just pinged on the continental slope. It took a second to go there and back. So remember, only half of that time is the time that you need to calculate the distance, because the other half is coming back up to you. Over here, we're over a little mini trench, and the boat takes 2 seconds. Over here is a seamount, and the boat takes 1 second, so it's half a second. Over here, we're over a big trench. Takes longer. Over here is a seamount with a little trench in between it. And then another calculation over here would be for an abyssal plain. The abyssal plain is where all the things in the ocean that die, it's where they go. And that's deep, so it takes longer. Now some trenches are deeper than that. In fact, the Marianas Trench is actually significantly deeper than that abyssal plain. Abyssal plain is usually 3,000 to 6,000 meters deep. So pause here for a minute and try your calculations out. And remember to divide by 2.